A rational number is a ratio of two integers. It is a formal way of referring to fractions. Now, we know that a fraction can be represented as a decimal number. Hence, these are two forms of the same rational number 3 by 2. We also know how to convert fractions to decimal numbers. And when a decimal terminates, it can easily be converted into a fraction. All we need to do is multiply and divide the decimal number by a suitable power of 10 and then reduce it. We also know that a rational number can result in a recurring decimal. So, how do we express a recurring decimal as a ratio of two integers with a non-zero denominator? Let's take 0.6363 and so on. Let's assume this number is x. The digits after the decimal point in this number repeat in a fixed pattern. Let's write this below our original equation. When we multiply this equation by 100, we get 100x on the left hand side and 63.6363 and so on the right hand side. This is our second equation. Observe how even in this number, the same two digits repeat after the decimal point. And now, by simply subtracting the two equations, we have managed to remove the repetitive decimal digits on the right hand side, leaving behind just an integer. While on the left hand side will be 100x minus x, which is equal to 99x. Now this equation looks like an integer times x is equal to another integer. Next, we'll move 99 to the right hand side to get x equals 63 over 99. The catch here is to multiply the number with the correct power of 10 to eliminate its recurring decimal part. So, to eliminate the recurring decimal digits in 0.8474747 and so on, we'll first multiply the number by 10. In the next step, we'll multiply the number by 1000. But why? It is simple. In this number, the only digits that repeat indefinitely are 4 and 7. So we need to make sure that after the multiplication, we leave only 4 and 7 after the decimal point. The equation for this problem will look like this. After subtracting the two equations, we get 990x is equal to 839. That is, integer times x is equal to another integer. On dividing both the left and right hand sides by 990, we get x is equal to 839 upon 990. Let's sum it up. First, we assign a variable to the recurring decimal number, and that's our first equation. We multiply both sides of this equation by a suitable power of 10, ensuring the same set of digits repeat after the decimal in the new number. This is our second equation, and on subtracting the two equations, we get a third equation, and integer times x is equal to another integer. Then, we move the integer on the left hand side in the third equation over to its right hand side, leaving only x on the left hand side. Finally, we reduce the fraction and we're done. A little complex, but nothing you can't master if you practice well. Good luck.